An electron experiences the greatest force as it travels 1.8 times 10 to the 6 meters per second in a magnetic field when it is moving southward. The force is upward and a magnitude of 2.2 times 10 to the minus 12 newtons. What is the magnitude and direction of the magnetic field? So this is really the same thing as the other problem where so it's just like in the other problem where we have the definition of a magnetic field, what the force would be on a plus 1 coulomb test charge moving 1 meter per second perpendicular to the field, and this is the formula that does it for you. FB equals Q times V times B. So for this particular problem, so the thing that we're after here is the magnetic field B, and we've got all these values listed here, so I just worked it out to get the B by itself. And then it's just a matter of tossing the numbers in your calculator. If you want to be really careful and not make any mistakes, you can use the e to the negative 19 and that sort of thing. Be careful not to type in e times 10 to the negative. Don't do that. If you type in e, you don't need to type the 10, or you'll make a mistake. But I got 7.6 Tesla. But the second part is actually probably maybe even harder, and it's asking for the direction of the magnetic field. And there's a little rule you need for that. So let me show you that. Hey, so the way that you get the direction of a force from a magnetic field is you use the right-hand rule. It looks just like this. So you just kind of make this shape with your fingers. And the way that it goes is this finger represents the velocity of the charge that's moving. This finger is going to represent the magnetic field, and then your thumb is going to represent the direction of the force. So it's V, B, F. And that's how you're going to figure out where the force goes on it. So in this particular case, they said that the thing's velocity was going south. So we can say south is like toward the back of the room, I guess. And then they said that the force ended up being up on it, which means the magnetic field would be pointing sort of inward towards me. I know you don't have that good of a view of it. Let me kind of try it this way. So it's like you've got the velocity is going toward the back of the room. It's hard to show this. And then they said the force was going up, so that's your thumb. So the magnetic field would be going this way. So let me jump back to the problem, and maybe I can draw it for you a little differently. So I kind of listed out the steps for you to do this exercise on your own. So first, face the back of the room, and then you're going to make that little goofy shape with your right hand. Make sure you use your right hand. This rule will not work with your left hand. It's got to be the right. Your index finger represents the velocity. So throw your index finger to the back of the room. Just point there. And then they told you that the force on it was upward. It's not north, but up. So point your thumb straight toward the ceiling. And then your middle finger is wherever it goes when you have your index going to the back of the room and your thumb going up. So your middle finger should be pointing to your left is how it'll work out. And if south was the back of the room, then your left would be east. So the right-hand rule will indicate that the direction of the magnetic field is east. However, there's one last problem. They told you that this was an electron that was doing all of this. And the definition for a magnetic field is what the force would be on a plus 1 coulomb test charge. So because of that, you actually have to flip this. So when you got the final answer being east, not a big deal. You cross it out, and you say that the magnetic field points to the west. Right-hand rule, definitely some easy points on a test as long as you don't get things mixed up.